Hello dear viewers, welcome to another video tutorial of this YouTube channel. In today's tutorial, we're going to be focusing on question number 10, which is coming from the ECZ examination for school certificate ordinary level additional mathematics paper 1. And the question that we're going to be interested in falls under the topic of vectors, and the paper it is 2024 additional mathematics, and it was for the internal candidates. Let's try to check where the question is located in this paper. So the question falls under vectors. So this is mathematics formulae. So let's try to check the location of the question. Okay, so this is the page that contains the question that we're interested in today's tutorial. And the question that we're actually interested in, it is question number 10, and that is the question that we're interested in. So the question itself has two parts. It has part A and part B, and part B further has two parts. So we're starting with part A. Let's try to go through this question. We're starting with part A. So part A states that find the vector equation of a line passing through the points A open brackets 3, 7 close brackets and B open brackets 2, -8 close brackets. So that question is carrying carrying 2 marks. And then we also have another part of this question, which is part B. Part B states that part B has two parts. It has Roman numeral 1 and Roman numeral 2. Let's go to Roman numeral 1. Roman numeral 1 states that find the value of t for which vector p is equal to ti plus 3j and vector q is equal to t squared I minus 9j are perpendicular. And then let's go to Roman numeral 2. Roman numeral 2 states that find the angle between vector A is equal to I plus 7j and vector B is equal to 2I plus j in degrees. So part B in total carries 7 marks, and then part A it carries 2 marks. So we have gone through this question, and before we get into the solving, I would like to advise you to subscribe to this YouTube channel so that you are always updated with the latest information on this YouTube channel. And as you are doing that, don't forget to turn on the notification button so that you are always notified when the latest information has been uploaded on this YouTube channel. And also don't forget to share so that others can also enjoy the tutorials of additional mathematics. And also don't forget to comment so that we can hear out your views. And also don't forget to like this video by simply giving it a thumbs up. Let's now quickly get into the solving. So let's now quickly get into the solving, and the part that we're starting with, it is part A. We're starting with part A. So part A, it is interested in the vector equation. The question itself, it states that find the vector equation of a line passing through the points A and B. So the coordinates of A and B we have been given. We have been given the coordinates of A and B, so we don't need to worry. The vector equation can be made. So how do we make the vector equation? How do we make the vector equation? So the way we make the vector equation is that you need to know the parts which make up the vector equation. You need to know the parts. So we have r. R is simply representing the vector. So r is representing the vector. So r is equal to a plus tb. So you need to know what of these are representing. So we are starting with A. A, it is simply representing the initial position vector. So A, it is representing the initial position vector. And then what about T? T is representing the parameter. T is simply representing the parameter. So this parameter can be represented by any letter or symbol. It can be a symbol such as mu, or it can be lambda. So this is how it is. So T is simply representing the parameter, which can be represented by any symbol such as mu. So what about B? B is simply representing the direction the direction vector. So we are simply going to work on these individually so that we have the vector equation. So we're going to start with B. We're going to start with B, which is the direction vector. We're starting with B, which is the direction vector. So according to the question itself, it has A and B. It has A and B. So in such a case, we can make the vector equation which can run from A to B. The vector equation can run from A to B. So that is how it is. So in such a case, since we are given 2 points A and B, so we're going to say the direction vector AB is equal to, so for you to know the direction vector AB, you need to say vector AB is equal to AO plus, so vector AO plus vector OB. So that is the way you can find the direction vector of AB. So you need to say vector AB is equal to vector AO plus vector OB. So now, how are we going to deal with these? So we're given 2 points. We're given that the coordinates of A are 3, 7, and then the coordinates of B are 2, -8. So what we're going to do is that we're going to say vector AB is equal to, so you need to know that the coordinates, the point A, when you consider the position vector, the coordinates which you are given, which is 3, 7, this is simply vector OA. This is simply vector OA. So vector OA has 3, 7. Vector OA has 3, 7. Now, according to this vector, which is vector AB, it is saying that vector AB is equal to vector AO. Vector AO. So how are we going to find the vector AO? So you need to know that this is the reverse form. So vector OA is 3, 7. And then what about vector AO? What are we going to do? That is simply the reverse form. So what we're going to do is that we are going to put the negative there, and then in the brackets we're going to represent this one, which is 3, 7 into the column vector. So the position vector, it is 3, 7. The position vector of OA, it is 3, 7 in column form. Now if OA it is 3, 7, what about AO? This will simply be the reverse form. So that is the reason why there is a negative there. So it will be negative and then open brackets 3, 7 close brackets plus, what about OB? OB we are already given. We don't need to add a negative since we are already given that it is going from O to B, which is the same direction. So in such a case, it is simply the same. It will be 2, 7, 2, -8. So that is how it is supposed to be. So vector AB is equal to negative open brackets 3, 7 close brackets plus open brackets 2, -8 close brackets, like that. And then the next thing that we're going to do is that we're going to consider the simplification. We're going to consider the simplification. That's the next thing that we're going to consider. So negative there, it will be negative times negative times positive 3, it will be -3. And then again there we also have to multiply negative times positive 7, it will give you -7, and then there it maintains to be a plus, and then it will be 2, -8, like that. So the next thing that we're going to do is that we're going to consider the simplification. We're going to pick the terms which corresponds to each other. So vector AB is equal to so -3 is corresponding with +2. So what we're going to do is that we're going to add those two, since there is an addition sign between those two vectors, which is vector AO and vector OB. So we're going to add. So negative 3 plus 2, it will give you negative 1. Again, there we also have another one which is corresponding to each other. We have negative 7 and negative 8. So we're going to say negative 7 plus negative 8, it will give you negative 15. So that is the direction vector that we're interested in. So the direction vector AB is equal to negative 1, negative 5, and that is in the column form. So that is the way we find the direction vector. And then the next thing that we're going to consider is that we have to find A, which is the initial position vector. Which is the initial position vector. What they mean when they say initial, it means that where it is starting from. Where it is starting from. So in such a case, we're given that AB, the vector, the line, it is moving from A to B. It is moving from A to B, meaning that our initial position vector, we're going to consider A, which is that one. So which has the coordinate, which already has the coordinates. So what is our A now? Our A, we are going to consider that one, which is 3, 7. 3,7. That is where it is starting from. It is starting from A going to B. So that is the reason why we have picked A. So we are going to represent that one into the column vector form. So in such a case, it will be 3, 7. And then our T, we're going to maintain it. Our parameter, we're going to maintain it as T. If you want, you can replace T with lambda or mu. And then what about our B? Our B, we say that it is representing the direction vector. So there is no need to worry. We already found the direction vector AB. So the only thing that we are interested in, it is to replace these things. So when we replace, it will be like that. So we have to say, therefore, R is equal to. So we have to say, therefore R is equal to 3, 7. So R is equal to open brackets 3, 7, close brackets. And then you need to mind that we can factorize this one instead of those brackets which are negative 1, negative 15. To maintain the negative in the brackets, we can take the negative outside the brackets. So in such a case, it will be minus T, open brackets, 115, like that, and then close brackets. So that is how it is. So therefore R is equal to open brackets 3, 7, close brackets, minus T, open brackets, 115, close brackets. So you don't need to worry. This is the vector equation. This is the vector equation, but there are a number of ways where you can represent a vector equation. So you can also use that one which has I and J. You don't need to worry. So in such a case, if you want to use that one which has I and J, I like the column vector way. So if you want to use that one which has I, so 3 is going to be I, and then 7 it will be J, and then 1 will be I, like that, and then 15 will contain the J. So you can do the simplification if you want to have that one which has I and J. But here in this video tutorial, we're going to end here. So R is simply equal to that one. So this is how you score marks in an exam room. This is how you're supposed to answer such questions. Let's go to the next part of this question, which is part B. Part B, we're going to start with Roman numeral 1. So Roman numeral 1 states that find the value of t for which vector p is equal to ti plus 3j and vector q is equal to t squared I minus 9j are perpendicular. So they're interested in the value of t. How do we find the value of t? So in such a case, we are going to identify the key things that we're given. We're given two vectors. We're given two vectors, which is vector P and vector Q. So now, another term that they have mentioned, it is perpendicular. What do they mean when they say two vectors are perpendicular? When two vectors are perpendicular, just know that the dot product is 0. So we're going to start by writing those two vectors. So that is how it is. And then as I was saying, so the perpendicular vectors, you need to know that the dot product is equal to 0. The dot product of two perpendicular vectors is equal to 0. So in such a case, we are simply going to do the to find the dot product. So we're going to say t open brackets ti plus 3j like that, and then open brackets t squared I minus 9j, that is simply equal to 0. So that is the way it is. So according to this video tutorial, we're going to use the column vector way. We're going to represent that one into the column vector because that's what I like. So we're going to get that one into the column vector form. So we're going to say t, and then there down we're going to have 3, and then in those other brackets we're going to have t squared and then negative 9. But you can use any other way. If you can, if you want, you can just use the direct way of addition and subtraction and also multiplication of these vectors. So that is equal to 0. So the way we work out with this one is that you need to multiply those. Since there's a multiplication sign between those two, we have to multiply the terms which correspond to each other. So in such a case, t is corresponding with t squared. So for that reason, we're going to multiply it with that one. So it will be t open brackets t squared close brackets plus. So some could be like, no, where is the plus coming from? So that is simply addition, because we are getting those which corresponds to each other. So in such a case, we have t squared, and then after you have finished with the one which corresponds to each other, you need to add. So we have 3 open brackets negative 9 is equal to 0. So the next thing that we're going to consider are the simplifications. So we're going to say t times t squared, it will give you the value of t cubed, and then there we have so we're going to say t cubed plus, again we're going to work out those individually. So when we say 3 times negative 9, it will give you the value of negative 27, and that is equal to 0. You need to remember that one. So that's the way it is. Again, there we have t cubed minus 27 is equal to 0, because positive times negative, it will equal to 0. It will equal to negative. So for that reason, we're going to make t cubed the subject. So it will be t cubed is equal to 27. So after you have done that, we are going to make t the subject. How are we going to make t the subject? We are going to cube root on both sides of the equation. We're going to take the cube root. So on the left hand side, we're going to have that one, and then on the right hand side, going to have that. So on the left hand side, we're simply going to have t after you do the simplification. So it will be t is equal to, so when you take the cube root of 27, cube root of 27 is 3. So that is the way it is. So t is equal to 3. So you even say therefore t is equal to 3. So this is how you're supposed to score marks in an exam room. I hope you're clear. If you're not clear at any point, feel free to drop the question in the comment section. So this is how you easily score marks in an exam room. This is how you're supposed to answer such questions. So let's go to the next part of this question, which is Roman numeral 2. So Roman numeral 2 states that find the angle between vector A is equal to I plus 7j and vector B is equal to 2I plus j in degrees. So they want us to find the angle between vector A and vector B. So how do we find the angle in vectors? So how do we find the angle in vectors? So you need to know that first those are the two vectors that were given. Those are the two vectors that were given. Let's try to write them. So now, how do we find the angle in vectors? How do we find the angle in vectors? So the way we find angle in vectors is that we have to say the dot product of A and B. The dot product of A and B. So AB is equal to the magnitude of A multiplied by the magnitude of B, and that is multiplied by cos theta. So in such a case, they are interested in theta. They are interested in theta. So for that reason, we're going to make theta the subject. So we're not simply going to make theta the subject at this stage, but we are going to make cos theta the subject. We're going to make theta the subject later, but right now we're going to make cos theta the subject. So for that reason, we're going to divide both sides of the equation by the magnitude of A multiplied by the magnitude of B. So for that reason, we're simply going to have cos theta is equal to AB, and then magnitude of A multiplied by the magnitude of B, like that. So this is how it is. So the next thing that we're going to do is that we're simply going to start replacing. Let's try to replace. So we're given two vectors. We have two vectors. We have A and B. So for that reason, it will be cos A or B. That is the angle which they are interested in. So cos A or B is equal to, so cos A or B is equal to, what is our A? Our A, it is, what is our vector A? So our vector A, it is that one which is I plus 7j, like that. Again, there we also have another one, since those two are multiplying, in case you lost. So those two are multiplying, vector A and vector B are multiplying. And then what about that one? We are down there, we're going to have the magnitude of A and the magnitude of B. So those two needs to multiply. So the next thing that we're going to do is that we're going to consider the simplification. We're going to consider the simplification. So again, we're going to get those which corresponds to each other. So when you check I and 2I, they correspond to each other because they both have I. So when you multiply, it will give you 2. When you multiply those, it will be 2. Don't worry about the letter where it has gone. 2, don't worry about that one. So if you want, you can take this into the column vector form so that you have the accurate one, so that you're not lost if you want. But in this case, we're not going to waste our time to take this into the column vector. So again, J and J are corresponding. So we have 7 and 1. So 1 multiplied by 7, it will give you 7. Again, down there we have the magnitude. What do they mean when they say magnitude? So in such a case, the way we find the magnitude, we have to say x squared. We have to say the delta x squared plus the delta y. In case you don't know what delta means, it is meaning the change. But in such a case, there's no change. It is already written for you. So in such a case, it will be 1 squared plus 7 squared, and then you need to take the square root. So you can refer to the way we find the magnitude in coordinate geometry, because these are somehow similar. So again, 2 squared plus 1 squared. So 2 plus 7, it will give you the value of 9, and then there inside the square roots, when you inside the square root, when you say 1 squared plus 7 squared, it will give you square root of 50. Again, there we have 2 squared plus 1 squared, it will give you 5, so it will be square root of 5. So don't forget, on the left hand side there is cos. There is cos A or B. So therefore cos A or B is equal to, when you consider doing the calculations on the right hand side, which are 9 over square root of 50 times square root of 5, it will give you the value of 0.569209978, like that. So the next thing that we're going to do is that we're going to make theta the subject. In such a case, our theta, it is angle A or B. So theta is equal to cos inverse of, so cos inverse of 0.569209978, like that. So when you consider saying that cos theta of that value, it will give you theta is equal to 55.30484647, like that. So even said that therefore at the end you can say therefore. This is how you calculate. So this is how you calculate the theta. If you are told to calculate the angle, this is the way that we use. So even say therefore theta is equal to 55.3 degrees. So how easy such questions are.